We're gonna take you into space on a wild ride. Across the big bright Milky Way, on comets we will glide.
We're gonna talk about the planets, telescopes, and stars.
With the cool intergalactic band from planet Mars. It's our home in space. It's our place. Home in space. It's our place.
When you look up in the sky, what do you see? If it is daytime, you see the sun. Do you know our sun is a star? It shines so brightly, we cannot see the light from the other stars. Our sun is the star closest to the Earth. It is the brightest object in the sky to us. The coolest stars are red, hotter ones are yellowish, still hotter stars are white, and the hottest ones are blue-white. Our sun is yellow-orange in color. And even though our sun is not the biggest, and it may not be the hottest of stars, it is still a gigantic ball of hot bubbling gases. Our sun provides all the heat, energy, and light we need right here on Earth. Our sun is very, very far from us. 93 million miles away, in fact. Our sun is the center of our solar system. There are planets, asteroids, and comets in our solar system, all going around the sun. Another object you might see up in the sky during the day is the moon, although you see it best at night. What about the stars? You can also see the stars at night. They look small because stars are trillions of miles from Earth, but they are really very, very big.
On a clear night away from city lights, we can see about 3,000 stars in the night sky. In the city where there are a lot of lights shining, you may only see a few stars.
A group of stars is called a constellation. People have named the constellations for the way they look. They have also named the stars in them. Long ago, they named the constellations after animals and the heroes of their stories. Some of the best-known constellations that we can see in the night sky are Ursa Major, also called the Big Dipper, or the Big Bear, and Ursa Minor, also called the Little Dipper, or the Little Bear. A meteor is something else we sometimes see in the night sky. Once in a while, a meteor will fall through our sky and light up. People call it a shooting star. When you look up in the night sky, you can also see some of the planets. There are 9 planets in our solar system. They are Mercury, Venus, Earth, Mars, Jupiter, Saturn, Uranus, Neptune, and Pluto. Some of the planets have moons and rings, like this. All the planets orbit our sun.
Orbit means to circle around. See how this planet is orbiting the sun?
This is a comet. Comets also orbit the sun. One scientist called it a dirty snowball because a comet is made up of ice, rock, dust, and gas. We see the tails of the comets in the sky. They are made of the gases or dust that flow out behind the comet. It might have 2 tails. There may be a dust tail and a gas tail. The tails always point away from the sun.
How do we know that what we know is really so?
The planets we can see from Earth by just using our eyes are Mercury, Venus, Mars, Jupiter, and Saturn. Mercury is hard to see because it's so near the sun. Most objects in space are so far away that we cannot visit them. All we can do is watch them from right here on Earth. Which do you think is further away, the clouds or the sun? We can tell that the sun is farther away by seeing that clouds move in front of it. Since most objects in the sky are very far away, we must use telescopes to see them. This is a telescope. And so is this. Nearly 400 years ago, a man named Galileo invented the telescope. Telescopes let you get a close-up view of the stars, so you can see things that are too small to be seen with your eyes alone. The neat thing about telescopes is that we are always seeing and learning about new things.
Sun flare, watching the stars show in the sky.
We use telescopes to observe many different things in the sky, like these clouds of dust and gas. Using a telescope, we can also see asteroids, which are like tiny planets. When our solar system was formed, not all the material was used up. The leftover pieces are called asteroids. With a telescope, you can see many more stars in the sky, many hundreds of billions of stars, in fact. This is Proxima Centauri, our nearest star besides our sun. You cannot see it without a telescope because it isn't very bright. Of course, we also look at the planets, their rings, and their moons with the telescope. In fact, we cannot see Uranus, Neptune, or Pluto without telescopes.
The earth is our home, our home in space.
Our Earth is one of the planets that orbit the sun. This is what Earth looks like from space. Our Earth is a huge sphere.
A sphere is a round object, like a ball. The Earth, the Moon, and all the planets are spheres.
As we stand on the Earth, it looks to us like the Earth is flat. It only looks flat because we just see a tiny part. Look what happens if we only look at a tiny part of this circle. Does it look round now? Earth is made mostly of rock on the inside, but on the outside, most of it is covered with water. It is even called the water planet. Everything on our planet Earth is pulled toward the center of the Earth. We call this special kind of pull gravity.
Gravity pulls everything on our planet towards the center of the Earth. This is why people do not fall off the Earth. Gravity is also the invisible force that pulls all the planets towards the sun, keeping them in orbit.
Our Earth orbits the sun in 365.25 days. A year is the time it takes the Earth to go all the way around the sun. If the Earth starts here, it will take 1 year for the Earth to get back to here. Sometimes, as the moon is orbiting the Earth and the Earth is orbiting the sun, they line up like this. This is called a lunar eclipse. A lunar eclipse is when the full moon, the Earth, and the sun are in line. It is when the Earth's shadow falls on the full moon.
Did you know that if you could drive in a car the 93 million miles from here to the sun, it would take 163 years to get there, and that's without stopping.
As we mentioned before, the sun provides us with all the heat, light, and energy we need to live. This is important because plants need this energy in order to grow. In fact, plants are the only things on Earth that can make their own food. Also, the sun does not warm our Earth evenly, and when some air is hotter and some air is cooler, the wind begins to blow.
The Earth is just the right distance from the sun for plants, animals, and people to be able to live on it.
The heat from the sun causes the water on Earth to evaporate. The water vapor turns into clouds, which in turn send water back to the Earth in the forms of rain, snow, sleet, hail, and mist.
The sun shines very bright every day.
Except at night.
It looks to us like the sun comes up in the morning, travels across the sky, and goes down at night. But the sun is not moving. It is actually the Earth that is moving. It is spinning like this. Another word for spin is rotate. We say the Earth is rotating.
Rotate means to spin around. Like this. When you are spinning, you are rotating.
If you were standing on the earth here, you could not see the sun. It would be night. As the earth rotates, you could just begin to see the sun. Daytime is beginning. It would look like this. As the earth keeps rotating, you would see the sun travel way up overhead, like this. The earth keeps rotating until the sun looks like it is close to the ground again. And soon you are moving to where the sunlight can no longer shine on you. It is dark again. One trip all the way around from night to day and back to night takes 24 hours. We call that one day. When the sun shines on Earth, the heat from the sun causes the day to be warmer. Nights are colder because there is no sunlight to warm the Earth. As the Earth is spinning, it is tilted like this. When the top half of the Earth is pointed toward the sun, it gets more sunlight.
So let's review. When the Earth is tipped towards the sun, it's summertime. And when the Earth is tipped away from the sun, it's wintertime.
Shine on, harvest moon.
It's my favorite tune.
Like the Earth, the sun also shines on the moon. As the moon orbits the Earth, we see different amounts of the lighted part. The same side of the moon always faces the Earth.
When we see more and more me like this, we say the moon is waxing. As less and less can be seen of me like this, we say the moon is waning. Waxing, waning.
The in-between part, like this, is called a crescent moon, and completely dark is called a new moon. It takes the moon 29½ days to go through all its changes. That is how long it takes the moon to go all the way around the Earth. A solar eclipse is when the sun, the new moon, and the Earth are in line. We see the moon's dark disk cross the sun's bright disk. When there is a full solar eclipse, you can see the corona or glow around the sun.
Remember, never look directly at the sun because you can hurt your eyes.
The oceans going up and down like this are called tides. Do you know the ocean tides are caused by the moon? The moon's gravity pulls the oceans out here and here, and pushes the oceans in here and here. This is what high tide looks like, and this is low tide.
Big, 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 big.
Space is big!
So now we know that all the objects in our solar system are very, very far apart. So far apart, in fact, that it is hard to imagine just how far apart things really are. And other stars are even further away. The distance to the brightest star we can see outside our solar system, Sirius, is about 54 trillion miles. That's beyond our understanding. The Earth is our home in space. We are near a star, our sun. We, along with 8 other planets, their rings and moons, asteroids, meteoroids, and comets, orbit the sun. The force of gravity holds them all together. We are part of the universe, and now we know a little of what is in it.
Bum 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 bum.
Way up in the sky, moon traveling by, stars twinkling bright. Now we'll say goodbye.
I'm Cassie. Welcome to Real World Science.
Real world science. Real world science.
In this program, we're going to learn to think just like scientists, using a process called the scientific method.
Real world science. Real world science. Science in the real world.
You may not realize it, but you think like a scientist every single day. Here's how. Whenever you ask a question and then explore the possible answers, you're using the types of skills that scientists use in trying to understand our world. That's what scientists do. For example, scientists who study dinosaur fossils, called paleontologists, ask questions about how dinosaurs lived and died. And they search for answers to their questions in the fossils they dig up from the ground. Scientists who are involved in space exploration pose questions about how people will react in the weightlessness of outer space. They perform tests and experiments to find the answers. Scientists who study creatures that live under the sea, called marine biologists, observe sea animals. Through their observations, they hope to find answers to questions about life in the ocean. You see, it is the job of scientists, no matter what area of science they work in, to ask questions and explore possible answers. And that's something everyone does. Take, for example, George. It's lunchtime, and he poses the question,
What kind of sandwich do I have for lunch?
How does George begin to answer that question? Well, he begins to gather information using one or more of his 5 senses. First, George smells the sandwich. Next, George looks at the sandwich. Based on his observations, he's able to come up with a possible answer. Scientists call this educated guess a hypothesis.
It smells like ham, and looks like ham, and there's cheese. It could be a ham and cheese sandwich.
George's hypothesis is that he has a ham and cheese sandwich. How can he be sure? He can experiment to test his hypothesis.
This tastes just like the ham I had the other day, and I taste American cheese.
Was George's hypothesis correct? Well, here's his conclusion.
I was right. It's a ham and cheese sandwich.
Now, George trying to figure out what he had for lunch isn't quite as complicated as a scientist unlocking the secrets of the universe. However, the process of finding the answer is very similar. They both use the scientific method, a step-by-step process that scientists have developed to help them solve problems and test new ideas. Now, there are different forms of the scientific method, and the order of the steps is not always the same for each problem. But for our purposes, we're going to cover the basic steps that scientists follow when performing a scientific investigation, also known as the research method. Here's the scientific method step by step. Step 1. Define the problem or question. Step 2. Gather information. Step 3. Form a hypothesis. Step 4. Experiment. Step 5. Make observations and analyze data. Step 6. State a conclusion. We can use the scientific method anytime we need to solve a problem or test a new idea. For example, David just started a paper route. There were no streetlights on his route, so David held a flashlight to help guide him along the way. One very rainy morning, David had to take an umbrella along on his paper route. He realized it was very awkward to hold the flashlight and the umbrella and deliver the newspapers too. When he tried to hold the flashlight in the same hand as the umbrella, David dropped the flashlight and it broke. So, for the rest of the paper route, David couldn't see very well, and he stepped in lots of puddles. David had a problem, and he needed to come up with a solution. So, he used the scientific method. The first step was defining the problem.
I can't hold the newspapers, flashlight, and umbrella all at the same time.
Next, he had to gather information. So, he looked through a catalog that had different types of lights, and he saw some with clips that could be attached to different objects.
Maybe I can attach a light to the umbrella so I can have one hand free to deliver papers.
David thought that if he attached a light with a clip to his umbrella, he would be able to see in the dark while he delivered his papers. And that was his hypothesis. Next, David had to test his hypothesis by performing an experiment. So, he made a light that looked like the one in the catalog by fastening a clip to a flashlight. Then, he attached the flashlight to his umbrella. He turned off the lights and tried walking through the dark room, observing what happened as the experiment went on. With the flashlight attached to the umbrella, he could see where he was going, and he still had a hand free to deliver papers.
Attaching a flashlight to my umbrella solves my problem.
David finally concluded that his hypothesis was correct. He thought that attaching the flashlight to his umbrella would solve the problem. So, he tested his idea, and the results of his experiment supported his hypothesis. Let's review those steps again. Step 1. Define the problem or question. Step 2. Gather information. Step 3. Form a hypothesis. Step 4. Experiment. Step 5. Make observations and analyze data. Step 6. State a conclusion. So, we've seen the scientific method in action when it comes to answering everyday questions. But how is the scientific method used to explore the world of science? Well, it works very much the same way. You've been to see a doctor before, right? Well, a doctor is a kind of scientist too. And just like any good scientist, doctors use the scientific method. For example, let's say a patient goes to see her doctor because she is sick. It's the doctor's job to diagnose a problem to find out what treatment will work best. Let's start with the first step.
What seems to be the problem?
Well, my head really hurts, and I think I might have a fever, and my body aches all over.
Well, the flu has been going around. Sounds like you have a lot of the symptoms. You might have the flu.
So, the doctor gathered information by asking her patient a question and made a hypothesis based on that information. She thought the patient might have the flu based on what the patient told her. But the first hypothesis is not always the correct one, and sometimes you have to repeat steps in the scientific method to come to a correct conclusion. So, the doctor decided to look into the problem a little further.
Let's take a closer look to find out why you're sick.
When the doctor diagnoses the patient, she gathers information about the problem by observing the patient's symptoms. The doctor uses her sense of sight to see whether the patient's throat is red or irritated. Then, she uses her sense of touch to feel the patient's neck to see if the patient has swollen glands. And the doctor listens to the patient's heartbeat and breathing. She also uses a thermometer to see if the patient has a temperature.
Well, you do have some flu symptoms, but I also saw some white splotches in your throat, and that's usually caused by strep bacteria. So I don't think you have the flu. I think you might have strep throat.
So, the doctor made a lot of observations. Then what did she do? Well, she formed a hypothesis. Based on her observations, she came up with an educated guess as to what is wrong with the patient. In this case, the patient's throat is red with white splotches, and she has a temperature. So, the doctor thinks that the patient might have strep throat. How does the doctor know whether her hypothesis is correct? She tests the hypothesis by performing an experiment. The doctor takes a sample from the patient's throat, then sends it to a lab where they will test the sample for strep bacteria. Using a microscope, the lab technician will observe the sample to see whether the strep bacteria are present.
Well, you do have strep throat. Now, I'm going to prescribe some medicine to take care of the infection, and hopefully with the medication and some rest, you'll feel better in a couple of days.
Okay, thank you.
You're welcome.
The lab experiment showed that strep bacteria were present, confirming the doctor's hypothesis. So, the doctor concluded that the patient had strep throat and gave her the proper medication for her illness. Let's take a closer look at how the doctor used the scientific method to diagnose and treat her patient. First, she gathered information about the patient's symptoms. Based on what she was told, she came up with an educated guess, or hypothesis, the patient might have the flu. Then, she gathered more information by examining the patient and realized her first hypothesis was incorrect. So, she came up with a new hypothesis. The patient probably has strep throat. Then, she tested the hypothesis by doing a lab test for strep throat. She observed the test results and analyzed the data. Finally, she came to the conclusion that the patient did indeed have strep throat. You don't have to be a doctor or a rocket scientist to use the scientific method. And you can even perform real scientific experiments. One winter day, Julie and Melissa were watching the weather on television.
Here in the town of Shoreline, the temperature is below freezing. Many of you will be happy to know that the Shoreline Pond is frozen and open for ice skating.
Great, now I can go ice skating.
And over at the Shoreline Beach, the temperature is also below freezing, so there won't be any swimming anytime soon.
Wait, if the pond water is frozen, why isn't the ocean frozen?
See that? Julie performed the first step in the scientific method. She defined her question. Now Julie and Melissa had to come up with an answer. So, Melissa went one step further and started to gather information, not from books, but from her brain, by remembering things she had learned in school about different bodies of water.
I'm not sure, but I know that the ocean is saltwater and the pond is freshwater.
Maybe it's the salt that makes the ocean water take longer to freeze.
And just like that, Julie and Melissa came up with a hypothesis. Salt water takes longer to freeze than fresh water. But how can they know for sure? Well, they could test their hypothesis by performing a scientific experiment.
We can try doing an experiment with some salt and water and put it in the freezer.
Let's try it.
So, Julie and Melissa set up their experiment. They decided that they would try freezing 3 cups containing equal amounts of water and vary them by adding salt to 2 of the containers. They would only test one thing or factor in the experiment: salt. The factor being tested is known as a single variable or experimental factor. When doing an experiment, it's important that you only have one variable. That way, you know that the variable is what causes changes in the experiment, nothing else. To ensure the success of your experiment, always measure carefully, so that all the factors, except your variable, are exactly the same. In the first container, Melissa added 1 teaspoon of salt to the water. And in the second container, she added 2 teaspoons of salt. The third container was just water, and that was their control. When you have a control, you're doing another experiment. The difference is that the control experiment is missing the variable. However, It is exactly the same as the experiment with the variable in every other way. The control helps show the importance of the missing variable. Let's go back to Julie and Melissa's experiment. After they prepared the salt and water mixtures, they put a popsicle stick into all 3 containers. That way, when the popsicle stick couldn't move anymore, they would know the water was frozen. They put all 3 containers in the freezer and observed them every 15 minutes to see if the water had frozen. Each time they checked the containers, they recorded their observations. Here's what they found out.
The water that had no salt froze in 15 minutes.
And the water that had 1 teaspoon of salt froze in 45 minutes. And the water that had 2 teaspoons of salt froze in 75 minutes.
The more salt we added, the longer it took to freeze. I guess we were right.
Yeah, salt makes water take longer to freeze.
And there you have it. Julie and Melissa used the scientific method and came to the conclusion that salt makes water freeze at a slower rate. All they had to do was use the scientific method to come to a logical conclusion. Did you notice how Julie and Melissa wrote down the experiment and their observations on paper? The observations that they recorded are known as data. It's important to outline experiments and record data so that other people can study your experiment and repeat it the exact same way to confirm your conclusion. When enough scientists repeat an experiment lots of times and have enough evidence to support a hypothesis, then it becomes known as a theory. A theory is a hypothesis that has been tested many times and is supported by data. So, why is it important for scientists to use a scientific method? Well, for one thing, it's a logical way for them to come to conclusions about the world around them. But it sets forth a standard that all scientists can use to understand and compare each other's information. And the more people we have working together to answer questions about the world around us, the more we can learn. As you've seen, you don't have to be a scientist to use the scientific method. Anyone can use the scientific method to come up with answers to all kinds of questions. Like, when the refrigerator door is closed, does the light really go out? Or why does soda make you burp? Use the scientific method and find out.